All right, what I'm going to do is I'm going to do this really quickly here. This is the retirement, and we're talking about the retirement in 5 years, 10 years, 25 years, and 30 years. I'm going to do the retirement in 5 years based on the calculations that we've put together. Now, what we've done first is to calculate out the total monthly contributions based on the salary, whether they're participating in the year's employees, what is matched, based on the year's employment, and so on. So there's a lot of information that's already gone into it. You can see this formula gets big, to say the very least. All right, so now what I'm going to do is we're going to talk about the retirement here, and this is the future value question. So in this case, let's just go in here, insert function, and again, you can always look for these and do, say, FV. We know it's future value. We'll look it up. Returns the future value of investment based on a periodic constant payment and a constant interest rate. I'm going to go ahead and click yes. So the rate here, what we're doing is, in this case, we're saying the rate is equal to a particular percentage. Now, in this case, we're going to say that the rate is equal to 7%, so that's 0.07. It could be a cell or a cell reference. If we wanted to, the number of payments is going to be 12 times 5, because it's monthly for the years, and then the payment amount here is what's being contributed. Drop that in here, J5, and we drop that in, and we have a sum of this value which is a little bit off. Now, if this is going to be, you want this to be negative as well, pulls it up. And you can see, so after 5 years, it is $610,611.45. Now, that's the 5-year plan. Again, so now if we pull this, you can see as I drag it down for people what the amounts are for 5 years. 10 years, basically, you can almost copy the formula. Drop it in here. Oops, sorry about that. Let's undo. And so, anyway, what I'm going to do is just drag this over. Let's do this drag over. And you could see things kind of go off. So you can actually, now you can adapt this one. This should actually still be based on that. Instead of K5, it's J5. J5. And now they equal. And what you're going to do is, instead of the 5 here, you could just change that to 10. Now again, this is assuming, as always, that this is at a 7% interest rate. If it's not at a 7% interest rate, if the interest rate is something else, there may be an investment interest rate. So let's change, I'll change this cell here, and we'll say that this is the amount of interest. So we'll say expected interest, APR, and this is your expected APR, and at this point maybe we'll change it to 9%, 9, and I can format this cell, format cells, and let's take this. Okay, that's fine. But let's go ahead and take this. I'll go home here and take this number, and instead of this being 9, I'm going to change this to percentage and change it back to 9%. All right, so now we have this at 9%. Now, if this is going to be a cell, we may want to do something different where we can then see what the expected rate may change here. So this is that rate here. So instead of this being 0.7, we are going to take this as being that cell. And I'm going to make this absolute value, F4. You can do it that way, or basically put in those dollar signs. Okay. So now you can see big going from 7 to from 6 to 7%, or 7% to 9% changes it a great deal. I can change this back, say, to 6, and it drops it back in. So you can now change your rate, and you can do things like drag it down and adjust it so you have your values based on a percentage rate, 6%. There's back at 7%. There's 7%. Again, you have that $610,000. So it's really simple if you think about what those arguments are. They are always what the rate is, what the number of payments are, and what the payment amount is. And again, this is for the basic, and if you want it to show positive, then you need to do it as a negative future value. So equals negative FV and continue from there. Hope that's helpful. Thank you.